Today we're going to be drawing Lewis structures, and before we start, let's just go over a few things. The first thing is you need to know valence electrons. So in case you forgot, I labeled them on this periodic table with these red numbers. So when I'm referring to numbers, valence electrons, these are the numbers I'm referring to. So if I were to talk about fluorine, for instance, I would be taking the number 7 from this periodic table and I would be using that in my math. So it's very important for you to remember your valence electrons. It's super simple. It's just 1 through 8. You skip the transition metals and you just count across. You also need to know the octet rule. So the octet rule essentially says that most elements, need 8 electrons to fill their outer shell. Okay, so some elements need less than that, like hydrogen, for instance, but a lot of elements, most elements, they need 8 electrons to fill their outer shell. So that's the octet rule. Okay, so we're going to be dealing with that a lot today. A few things that I labeled here or colored on this periodic table is that pink, these C, carbon, nitrogen, oxygen, fluorine, these elements must always satisfy the octet rule. Okay, no, you can't have any more electrons or any less electrons. They must always have exactly 8. The other elements that I labeled is hydrogen. So hydrogen could only have 2 electrons. So this is an element that only has 1 valence electron. So it could only share that 1 electron. Therefore, it could only form 1 bond, okay? So a bond, one bond, which is a line like this, represents a bond, and it represents 2 electrons, okay? And another thing that we're going to be using today are 2 dots that are next to each other, and these are known as lone pairs. Okay, so the bond is a shared pair of electrons, and a lone pair belongs to whatever element it's on, and it only counts towards the element that it's on. And you'll see what I'm talking about in a second. Beryllium could only have 4 electrons, and boron could only have 6 electrons. Okay, so hydrogen forms a single bond like this mostly. Beryllium, you'll see it with 2 bonds. And boron, you'll see with 3 bonds. And then the rest have to have 8. Okay, so the rest are going to have 8. The elements that are labeled in this like light blue color they must have at least 8, but they could have more. And that's called the expanded octet. So they have to have at least 8, but sometimes they could carry more. Okay, so we'll do examples of that as well. Okay, so here are the steps for drawing a Lewis structure, and I tried to give you as much information as possible without it being overwhelming. So I'm going to do an example. I'm going to do a few examples actually. So the first one I'm going to start with is the easiest one, which is water. So H2O. So that's going to be the first one, and that's usually the first one that everyone uses. And the first step says calculate the total number of valence electrons. So the total number of valence electrons would be the number of each atom, okay, the subscript of each atom times its valence electrons. So here I have hydrogen and I have oxygen. I have the subscript of hydrogen is 2, so that means I have 2 hydrogen atoms in this molecule. And oxygen doesn't have a number, meaning that it's 1. And if I were to look at the periodic table, I would see that hydrogen has 1 valence electron, whereas oxygen has 6. So that gives me a total of 2 here, total of 6 here, and then in total I have 8 electrons. Okay, so these electrons are going to be the ones that I'm going to distribute around the molecule, and you are not allowed to have any more or any less than that number. So you are limited to 8, okay? I'm going to be doing math on the side here, so I'm going to put 8 valence electrons here so that as I'm going along, I'm bookkeeping, okay? It's important that you keep track of your electrons as you go along. Okay, so the second step after that is to draw the skeleton. What that means is you're just connecting the atoms. So you're going to have, in most cases, a center atom and then a bunch of surrounding atoms. So for this one, you're going to have oxygen in the center. And then hydrogen is going to come on the outside. So usually what happens is the element that's written first is the center atom, except if it's hydrogen, which is never the center. Or if you have carbon, carbon is always the center. Okay, if you don't have carbon or hydrogen, whatever element is written first is most likely your center atom, okay? And that's the one that you're going to put in the middle, and everything else surrounds it. And keep in mind that every line represents 2 electrons. So I have 8 total, and I just used up 4 because I have 2 lines. So just remember that each line, this is 2 electrons here, and that's 2 electrons there. So I just used up 4. So now I have 4 electrons left. Okay? So the next step says add remaining electrons as lone pairs. So remember from earlier, lone pairs are the 2 dots. And usually it's going to be on the surrounding atom, but in this case it's not. Okay, since the surrounding atom in this case is hydrogen, we can't put it there, so we're going to put it on the oxygen. So I have 4 electrons left. Okay, so I have 4. And oxygen right now has 2, 4, so it needs 4 more. So I'm going to put them as dots, and the dots have to be in pairs. Okay. You have to make sure that it's clear that they're in pairs. So right now I just used up 4, so I have no electrons left in that step. Okay. Now it says check for the octet. So I'm just going to draw this here again. I keep redrawing it just so that it's clear what I'm doing in each step. So let's count it. So hydrogen has 2 and this hydrogen has 2. So each hydrogen has 2 electrons, so that's good because that's the max that it's allowed to have. You are not to have anything else other than 1 line on hydrogen. So let's check oxygen. So this line counts towards hydrogen and oxygen. So that's 2. And this one also counts as both. So that's 4. So right now I have 4, 5, 6, 7, 8. So oxygen has 8. So then this structure is done and you're good. So let's do something a little bit more challenging. Let's try nitrate. Okay, nitrate, which is a polyatomic ion. Okay, so in this case, you do have a charge, so you have to take that into consideration. So let's look, we have oxygen, we have nitrogen, oxygen, and then we do have a charge. So we have 1 nitrogen, 3 oxygens. I have 5 valence electrons from nitrogen, and I have 6 from oxygen. And these numbers, again, I'm getting from the periodic table, the red numbers from previously. And I have to add 1 to it. Okay, so you have to add 1 because of the negative charge. So if it's positive, you subtract an electron. If it's negative, you're going to be adding an electron. Okay, so here you have 5 plus 18 plus 1. So my total here is 24. Okay, so my total is 24. So I'm going to draw it here. Okay. So in this case, nitrogen is going to be in the center. It's written first. And I'm going to draw the oxygens surrounding it like that. And I just used up 2, 4, 6, right? Each line is 2. So I just used up 6. So I have 18 left. Okay? So I just drew the skeleton. Next is add remaining electrons as lone pairs. Okay? Of course, when you're doing this, you don't have to keep redrawing it. I'm just redrawing it because you're learning this. So I have 18 electrons here. And I like to do surrounding atoms first if I can. If it's not hydrogen, I like to do surrounding atoms first because it keeps it symmetrical for me. It's easier for me. But you could do however ways easier for you. So I have 18 electrons left. So I'm going to focus on oxygen right now. So each oxygen right now has 2 electrons. So each one needs 6 more. So I'm going to go in and give each one 6 lone pairs. Keep in mind, lone pairs count only towards the atom that it is on, but bonded electrons count towards both atoms that they're connecting. Okay, so I just used up 18, right? Each one got 6, so I have 0 left. So now if I go to the next one, now it says check for octet. So what I'm going to do here, I'm going to count each one. So each oxygen has 8. I know that. So that's good. If I were to check nitrogen, right now it has 3 lines, so that's 6, so that's not good. So I need to actually move electrons around to make sure that nitrogen could get that 8. So what you do in that case, so just if you see under the rule, it says if you need more electrons but have 0, you need multiple bonds. So you need to make a multiple bond, and just be careful not to go to multiple bond crazy, because that's what a lot of people do. They just double bond everything or start triple bonding. You're only going to do it as needed. So right now, nitrogen has 6, so it needs only 2 more. So you're going to take this oxygen, the lone pair on this oxygen, you're going to make it share. So then your final structure is actually going to be 1 double bond, okay? Okay, so then now if you were to look at it, nitrogen has 2, 4, 6, 8. So it has 4 lines, which is 2 each. That's 8. This oxygen has 2 lines and 2 lone pairs. So that's 8. So all of them have 8. And if you have something with a charge, you need to draw brackets around it and then the charge on the outside. So then this structure is done. Everything has 8 and you're good. Okay, last example. Let's do carbon dioxide. So in this compound, you have 1 carbon and you have 2 oxygens. Carbon has 4 valence electrons. That gives you a total of 4 from carbon, 6 from oxygen. So 6 times 2 is 12. So here you have a total of 16. Okay, so those are the electrons that you have that you could distribute, no more, no less. So in this case, you have carbon in the middle, 2 oxygens coming out of it. Okay, so let's bookkeep on the side, 16. I just used up 4 because 2 bonds, and I have a total of 12. Okay. I'm going to work on surrounding atoms first. So I have 12 electrons here. 1, 2, 3, 4, 5, 6. That gives me a total of 8 on this oxygen. There's 2 here. 4, 5, 8. Okay, now both of them have 8. And I used up all 12. So if you look here, each oxygen is good. Each oxygen has 8 electrons. Carbon in the center only has 4. So this is a case where you're going to have to form more than 1 double bond. So if you were to do the double bond only once, so I'll just draw it for you just so that you could see. If I were to do only one double bond, carbon still doesn't have enough. Okay, so this wouldn't work. So you need to do a double bond twice. Okay, so now if you look at carbon, carbon has 4 lines, which means that it has a total of 8. And then each oxygen has 8 now. So this structure is good, and that's your final answer. So just keep in mind that if you want a double or a triple bond, you have to do it as needed. If you double bond one atom, doesn't necessarily mean you have to double bond all of them. You just have to kind of figure out how many you need so that you're not, just double bonding everything or not double bonding enough or triple bonding, whatever the case may be. Okay?